there's people here. This is fantastic. I'm not used to this. They also gave me a controller, and it's got a laser pointer. That's fun. We'll get going in like 10, 15 seconds. If Sean has to sit down. Well, let's just get started because it's 11:30 and this is my time. So hi, my name is Joel Talley. I host a show called 3D Printing here. You may or may not have heard of it. The goal is always to inspire and educate and have a really good time. I hope you have a really good time when you're watching the show. You may have seen I finally completed a project that I called the world's largest OpenRC. I know it's no longer the world's largest, but that doesn't matter because at the time it was. And there were a few videos and it took the course over more than a year, and I figured I could take a little bit of time here to give you guys kind of a behind the scenes look at some of the stuff that we went through, some of the stuff that may not have made it to camera, 5 or 6 things that just might be cool things to know about the project. See, how to make a really big RC, some behind the scenes nuggets. I even titled it that way. So the goal, how's that look? Boy, text is hard. I have a goal to talk about what happened behind the scenes during the build. I used a template from Google Slides, and I like this one, so I kept it in. Unexpected, emotional, awesome. These are great words to talk about things. Some of the pieces were going to be bigger than those machines could produce, so we had to come up with a way to intelligently and digitally slice the pieces before sending them to the printers. That word there, intelligently, I really want to talk about that because normally when you take something and you embiggen it, you want to slice the pieces in, like I said, an intelligent way, a way that makes these pieces easy to put together afterwards. And I did not do that. And believe me, I caught lots of crap for it on the internet. And so what I did, I essentially went into Mesh Mixer and just made these straight cuts, which then ended in butt joints. And it means that, what's the right way to say it? The strength isn't in the joint. And everybody said, your car's gonna fail. I was like, no, it's not gonna fail, I'll reinforce it. But if you ever go online and you make an instructional video about how to make something bigger, and you make cuts, don't just do straight cuts, please. For the love of God, do it better than I did. That's not bad.
That is cool.
That's not bad. That was actually really bad. So if you look right here, this is the wishbone part. And you can see there's some blue tape around it. We had some clamps around it. When that was shipped to the Midwest Rip Rap Festival with Daniel Loran, I put it together, that broke apart like crazy. And it was because this part right here, I didn't slice in the right spot. So what I did is I sliced it here and here, thinking that these lobes would print the easiest. I printed those in the Raise N2 Plus. That's a big machine, so I could print these parts really big, and this small one I could print, and I thought, hey, we could put some in there just to hold it together. That didn't work at the time. Thankfully, there's a product called 3D Glue that I endorse and I like, and it works. And I was able to, before we ran it the last time, put it right here at the wishbone. And I was able to hold this and move it around in the air. So one thing to take into consideration if you're ever going to do a project like this, make sure you use the right adhesive for the job. This was all PLA, and this is why I used 3D Glue, and it worked great.
And those layers are like butter. They're like butter. Oh man. Oh man. Well, if you're going to put your flexible material, make sure you dry it out first because then it is epic.
It is truly epic if you dry your flexible material first. One of the things I learned through this, I mean, we all know, right? We all remember, people say you need to dry your flexible material, right? It's hygroscopic, it's going to absorb water over time. And if you're extruding it, that water boils at the nozzle and creates imperfections. And I believe I showed one of the wheels that went bad in the video that I made for this. You need to dry it out. The problem I ran into is this is the Lowspot TAS 6. Rest in peace. Too soon? These tires actually took more than 30 hours to print, each of them. And this is the Matter Hackers TPU, which comes on a smaller roll. So I had to switch, sometimes I had to switch a roll in between the print. another lesson to learn from this, the TAS6 has a pause function in order to change out the filament. I hadn't used it before, and the print was going, and it was getting to the part where I had to change out the filament. So I thought, hey, Volkswagen has a 24-hour helpline. I'm going to call them, and I'm going to find out what this means. So I dialed them up, I called them up, and a nice young lady answered the phone, and I posed my question, how does the change filament function work in the TAS6? And she said, I don't know. So again, if you're ever going to do a project like this, learn your printer, maybe do some tests first of certain functionality in case you need it. Also, don't forget to dry your filament.
Look at that. There's no bearing in there. This is 100% 3D printed plastic, including the screws. And it's spinning just fine. I wonder what would happen if we had all 4 tires, rims, all 4 wheels using 3D printed bearing shapes. I wonder if it would work.
Oh, yeah.
Wow, totally dug into plastic right there. Looks like that bushing.
It didn't look at all. And it was the whole reason the car didn't run the first time. I know the internet, like all of the internet told me this is going to fail because plastic on plastic is just going to melt. And I was like, that's not how that works. It's exactly how it works. No matter how much lubrication or graphite powder or whatever we did, once we moved into bearings, it worked great. And hopefully in the last episode you saw that the bearings worked great. And we went up the hill, we crashed into a Tesla. It was wonderful. One of the things that you should take from this, though, is while 3D printing is absolutely wonderful, I'm one of the most fervent proponents of 3D printing. It can't do everything, and if you're going to embiggen something that might need parts that roll, look into finding bearings. And that's what I talked about in one episode where we had the shims. We made the shims so we didn't have to buy custom bearings. Custom bearings can run you a lot of money. But if you find stuff that might fit and then do 3D print parts to make it fit, it's awesome. And that's what I did. The other thing we need to talk about is get to know your parts before you put it together. So when I originally produced this episode and put it up online, it was titled 3D Printing Bearing Shapes. And everybody said, Joel, that's a bushing. Okay, so at 2 o'clock in the morning, apparently my mind had forgot the word bushing. And the internet let me know. So just make sure, before you do any projects like this, you learn what you're using. I was using bushings. I learned that now, and I will never forget. This very sexy looking piece of electronic equipment in front of us, is this what we're going to use to control the car?
This is what we're going to use to control the car.
This looks like something that you use to radio control a Tesla, or maybe launch things into multiple things into space or something.
So it's actually a 32-channel radio.
It's 31 channels more than what we needed. That was complete overkill, and I should have known better. So the reason that we use this is because this gentleman here, Robert, this is his, he owns it, he knows a lot about RC, and he thought we could just use this controller that I have. It has plenty of channels, don't worry about it. You'll be able to run your car. It'll be easy. And when running the car, it wasn't easy. You know the controllers that are, you have this grip, and then you have the steering wheel, right? That's what I wanted for the car, and that's what I didn't have for the car. And it's funny that I mentioned that could radio control a Tesla, because like I said, we ran into a Tesla. But hopefully the next episode you see of this, we'll swap out that controller for something a little bit better and probably adjust the brake on the speed controller so we don't hit another car. That's the goal. So if you're going to do a project like this, make sure you're using the right equipment. A lot of people tend to use things that they already have, right? You make with what you have, but if there's something specialized that will do the job better, sometimes it's better to invest in that. And that's a lesson I learned here. Our box, got our box of fasteners, and big thanks to Dick at Tacoma Screw. Awesome dude. Dick at Tacoma Screw was an awesome dude. That's his real name, and that's a real show. What's great though, with this, I want to make sure you know, with this OpenRC project, I went and just made everything bigger by 4x. That included the nuts and the bolts and stuff, and which is why I went to Tacoma Screw and spent $70 on bolts. It was terrible, and it was just because I sized something up. I could have easily went and found sizes that would have worked and saved money and still had plenty of attachment there to keep the car together. But I didn't. And so if you're ever going to do a project like this, I think it's important to plan ahead so that you can save money on hardware and use that money for milkshakes or something instead of extra hardware. So this is really the conclusion of this little presentation. I just kind of wanted to give you a background. We can open it up to Q&A here in a little bit. This slide was part of the template, and I left it in because I thought it was awesome. How many languages do you need to know to communicate with the rest of the world? Just one, your own. And I'm living proof of this. So if you ever think about showing the world what you do, what you make, what you create, don't try to replicate what other people are doing. Use your own voice and show the world in your own style how cool what you did is. That's my advice, really. Just be awesome, be good humans, and be sure to love each other more. Before we go, though, I do want to bring up a couple of people. So I started in my office late at night between 11 p.m. and 3 a.m. shooting videos. I wore a hat during the day and I took it off, and that's why my hair went crazy. And it just works, so I just leave it crazy. But since then, I brought on a team. I have a team of people now. First is Sean. Come on up here, Sean. So you guys know Sean. Sean, I brought him on as my editor. He also produces some segments. And what's great is in Hollywood, a producer-editor is known as a predator. So Sean is my 3D printing predator right here. Yeah, please do. And next, come on up, David. So this is David Tobin. He's my executive producer. And what's great about David is he's worked on TV shows that you've probably seen before, like Biggest Loser or Dancing with the Stars. I've known him for years, though, and at one point he was like, I think I could help with your show, Joel. Let's see what we can do. And sure enough, we have a lot of really exciting opportunities ahead of us. So thank you, David. There it is. Okay. Well, thanks for coming. If anybody has any questions, I'm more than happy to answer them, or you can get 15 minutes of your day back. Great, let's see a question. Thanks for that. We're going to get you a microphone just to make sure everyone can hear you. Crowd line. Nick will be up there.
Lovely work, Joel.
Thanks.
And yours, Ron. How do you decide to, when you face the exotic $70 screws, to not just reprint the part or make a missing fit a common screw versus going ahead and make the exotic screw? What was the decision process?
Well, behind that, the reason I went with that is because I knew it would work. I knew it would work, and it was going to be within a time frame that I had. So reprinting parts just wasn't really possible at this point because of the size of what they were at, and I was under a crunch just to get this done. And so for me, at that time, a $70 order of hardware from the hardware store is much better than the week or two it would have taken to reprint certain parts. So that was my thinking process there. Anyone else? Right over here. Run, Nick.
Thank you, Joel, for all you do. What do you do, and how much storage do you have for all those prints?
Say that.
What do you do, and how much storage do you have for all those prints that you've done?
Okay. We've run out of room in the house long ago. I took over a room up in the top of the house, and then I took over a side room, and half the garage is mine now, and I'm kind of encroaching on the rest of the garage, which is sad because my wife would really like to park in the garage, but it's just not possible. Some of the prints get donated or given away. Some of them, unfortunately, end up being recycled. 3Devo did send over a filament extruder, which is going to be better than that other one, So I'm going to actually recycle some prints into filament that I'm able to print stuff with. But right now, we're running out of space. There's just not enough space to contain everything, let alone all the equipment we need to film and produce the content. So we're looking into solutions. We'll see what happens. Hopefully my wife can still park in the garage. Question up front, Nick.
So you're still doing resin printers?
My what?
You're still looking at resin printers?
Oh yes, absolutely. We've got, so I did the Orange 10 from Longer. That was one of the first ones other than the Form 2. They've sent off the Orange, the Longer 3D Orange 30, which was a Kickstarter printer that I'm going to get out of the box soon. Mars sent over the Alagoon, and that performed really well. Most recently, though, I've tweeted about this, and we'll have the episode out next week. The Piopoly Phenom, actually see the table over there. It's this monstrous 400 millimeters on the Z resin-based 3D printer. And you know, the bottles of resins for a 3D printer, usually the smaller ones, you just pour a little bit into the tank and you're good to go. This one, you pour the full bottle, and then you take a second bottle and you pour that one in too. It takes a liter of resin. It's crazy. It's crazy. So the goal is always kind of showcase what's new, what's cool, what's awesome. Low-cost resin and new resins are very interesting, and there's some considerations that go along with that. So the goal is to kind of showcase that, but also make sure that the people that watch the episodes actually know about the dangers and the warnings with the safe handlers, right? I can't recommend it's not like, hey, give a table saw to your 9-year-old. It's like, no, work with your 9-year-old to safely handle it. Table saw supervised, so that's where we're going with that.
So you mentioned 3D Go 60.
Let me get my speaker. Okay, say it again. 3D makes an interesting product. So they have a filament extruder. They also have a filament recycler grinder, and they have a drying system. It's interesting because their target market isn't most people here. The filament extruder is like $7,000 US. And they're more of a business-to-business sort of relationship. But what's really cool about what I do is I can show this really cool technology to people that then might go into the industries or the businesses that are going to use this product. So there's huge value there. Plus, I know I make bacon filament with rotopasta. I'm going to have to try to make some bacon filament at home just to save more coffee. It'll either smell like breakfast in my house or it'll be terrible. I don't know. I hope that I haven't even gotten it out of the box yet. But it's in the queue. It's not that long. The queue. It's that long. It's just full of awesome things. Thanks for the question. I think we're good. Okay, thanks for coming. I really appreciate you coming by, and I look forward to talking to everybody. And have a good rest of Earth.